Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's a problem for today. It's a problem that was once on exam M, which later on became exam MLC and MFE. It's actually a very nice probability problem, so I use it as an exercise for exam P. A Mars probe has two batteries. Once a battery is activated, its future lifetime is exponential with mean 1 year. The first battery is activated when the probe lands on Mars. The second battery is activated when the first fails. Battery lifetimes after activation are independent. The probe transmits data until both batteries have failed. Calculate the probability that the probe is transmitting data 3 years after landing. And here's the solution. So let x be the future lifetime of the first battery and y be the future lifetime of the second battery. But both of them, the probability density function is of the same form. It's the exponential distribution with mean 1. So it's e to the minus x. F sub x of x is e to the minus x for x positive and 0 otherwise. And f sub y of y is e to the minus y for y positive and 0 otherwise. And we also know that x and y are independent, and we're looking for a probability that x plus y is more than 3. The probability can be found if we know the probability distribution of z equal to x plus y, and this can be obtained by using convolution. F sub z of z is f sub x plus y of z, which is the integral from 0 to z of f sub x of x times f sub y of z minus x dx. It's a standard convolution formula. And that becomes the integral from 0 to z of e to the minus x times e to the minus z minus x. So the part with e to the minus x and e to the x cancels out, and this is the integral from 0 to z of e to the minus z dx. Well, what is that? This is not a function of x, e to the minus z. It's just the constant with respect to x. So this integral is simply the length of the integral from 0 to z, which is z, times the constant with respect to x, which is e to the minus z. So z times e to the minus z for z positive. Of course, you should have expected this answer as the sum of two independent exponential random variables with the same mean as gamma with parameters alpha equal to 2 and beta equal to the mean of the exponentials. And therefore, the probability that x plus y is more than 3 is the probability that z is more than 3, which is the integral of the density from 3 to plus infinity. And I just changed the variable, call z equal to t plus 3. So it's the integral from 0 to plus infinity of t plus 3 times e to the minus t plus 3 dt. And we can factor out e to the minus 3 and put it in front of this integral, and then we have the integral from 0 to plus infinity of t times e to the minus t dt, plus 3 times the integral from 0 to plus infinity of e to the minus t dt. So it is e to the minus 3 times this integral from 0 to plus infinity of t e to the minus t dt. Well, this is, there's a variety of things you can say just immediately to see that this is equal to 1. First is that this is the gamma function evaluated at 2, so it's 1, because it's 2 minus 1 factorial. It is also the mean of exponential with the hazard rate of 1. Or we just established that this was the density of the probability distribution of z. It was z times e to the minus z. Well, the integral of a density has got to be 1. So whatever way you look at it, this is instantly evaluated as 1. And then the second part is 3 times e to the minus 3 times the integral from 0 to plus infinity of e to the minus t dt. All right, so this is gamma of 1, which is 1. Or it's the mean of exponential with lambda equal to 1, because by Darth Vader rule, it's the integral of the survival function. Or simply an integral of the PDF of exponential with the hazard rate of 1. Whatever way you look at it, it's instantly you know that this is 1. We don't calculate integrals where we know what they are. And we know these two integrals to be 1. Oh, so therefore, this is e to the negative 3 plus 3e to the negative 3. And that's 4e to the negative 3, which is approximately 0.20, and that's answer D. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.